Alright, we've edge found, so now we're ready to go ahead and put the 4 holes in our part. Drilling a hole is going to be a 2-step process. Anytime we're going to put a hole through our part, we want to do what's called center drilling first. And the center drilling is going to do a couple things for us. It's going to give us the ability to double check our numbers and make sure that we're in the right spot. And it's also going to give us a slight dish or indentation in our part that the next size up drill, or the drill that we're going to drill through the part, has a place to go, and it will help follow or guide that drill in the correct location. So a center drill is going to look something like this. This is a number 4 center drill. The number refers to the size of the center drill. And what I'm going to do is I'm going to go to the 4 different points on our plans and use the DRO and the coordinates that are given, okay, with the dimensions, to locate and center drill at these 4 locations. So the center drilling, our RPM is going to be at about 1200 RPM. Anytime we drill, we're going to use lubricant. Okay, each mill should have one of these on it. This is a jar with oil and a brush, okay, that we're going to place. Either we're going to put some oil either on the drill bit or on the surface of the part. So I'm going to turn this on and go to 1200 RPM. And now what I'm going to do is I'm going to go to my dimensions that I found on my plans. And the first hole goes here, and according to the plans, it's 500 thousandths in X. So I'm going to watch my DRO and go to 500 thousandths. Okay, and then in Y, I'm also at 500 thousandths. So I'm going to go to 500 and 500, and that should be right where I need to have that hole drilled. So I'm going to put a little oil, and I'm going to go ahead and drill this hole. Now when you center drill, we want to drill until we get to just the wide part or the flare of the center drill. Okay, so somewhere about that deep. So if I stop this and we clear out those chips, you can see that I've got a hole that slightly flares toward the top. Okay, that's what we're shooting for. So I'm going to repeat this process on the other 3 locations of the other 3 hole locations on my part. So the next one is going to be the same 500 in X, but in Y, I'm at 1.562. So we go to 1.562 on the DRO without changing our X. And I'm going to go ahead and a little dab of oil. I'm going to re-drill this. Okay, notice sometimes you may need to go down a little bit and then up. That helps clear chips out. Okay, my next hole is going to be at 3.4 in X. So I'll head over to 3.4. Okay, my Y number shouldn't change. So again, dab of oil. Okay, and then finally, my last hole is at 500 in Y without changing my X dimension. Alright, so now what I've done is, using the combination of the edge finder and my digital readout, I've placed 4 center holes in the location of the 4 different holes on my part print. Alright, we've center drilled all 4 points now. Now it's time to go ahead and either drill a through hole to prepare for a ream, or drill a through hole to prepare to tap or thread a hole. We haven't changed any settings on our DRO, so we can still use those numbers that we found after we edge found our part. We're going to start with the threaded holes. When we thread a hole, we have to drill what's called a tap hole first, and the tap hole is slightly smaller than the threaded hole will be. You're going to have to look through a chart to find the correct size tap drill for whatever thread you're going to use, or whatever thread size is called out for the hole. So on our plans, we have 2 holes that are threaded. Right? These 2 opposite corners are threaded. Okay? Our call out is this 5/16-18. That's a 5/16 by 18 screw will fit in there. So it's 5/16 screw that has 18 threads per inch. Now, to figure out the size of the tap drill we need to create this hole, we need to consult a chart here. On the chart, I'm going to find my tap size, okay, 5/16 by 18, and right next to it, it'll tell you what size drill you need to use for your tap drill. So that's an F-size drill. I went ahead and I got an F-size drill, and I've loaded it up into the chuck, and I'm ready to go ahead and drill this. We're going to turn the machine on. We're going to set our RPM per our calculation, which is somewhere in the neighborhood of 1600 RPM. We're going to drill this hole all the way through. Now, when you drill a twist drill like this all the way through your part, you're going to get very long shavings. Okay, so you're going to want to position yourself so that you're standing back kind of a little bit, so you don't get whacked with all those shavings coming off. And we're also going to need to make sure we use lubricant as we go through this whole process. So I'm aligned with my point, which is negative 0.4 in X and positive 0.5 in Y. That's my bottom right hand hole. We're going to drill this hole, and then we're going to move to the top left hand corner to go ahead and drill that second tapped hole. So we're going to turn ourselves on, head up to 1600 RPM, and we're going to get ready to drill here. So a little bit of oil. Okay, and you're going to have to drill a little bit faster, or move this a little bit faster than you think. Okay, and periodically bring the drill bit up to clear the chips. Add a little bit more lubricant. When you feel like you're about to get to the end or the bottom of your hole, slow down your feed, okay, so it doesn't pull the drill bit through. So nice and easy at the end there. Here it comes, and there I've broken through. Okay, bring it up. Turn the machine off, clear out your chips. Never use your fingers. Okay, use a brush. Okay, so now that hole is perfectly sized for a 5/16 18 tap. I'm going to go ahead and head to the top left now, which is going to be 0.5 in X and 1.562 in Y, I believe. So 0.5 in X and 1.562. So that should now line up with my center drill nicely. Okay, we're going to repeat the process. Lubricant, drill on, okay, and we're going to work a little bit, clear the chips. A little bit more lubricant if you need it. A little further, clear the chips. Okay, this should probably be my last pass here. So again, I'm going to go, and when I feel like I should be popping through, I'm going to slow down the pressure on my feed hand here until that just comes through there. All right, again, turn the machine off, clear the chips with a brush, and clear the chips off your drill bit. So that is how you're going to pre-drill or tap drill prior to threading that hole. Okay, the other 2 holes that we need to drill in preparation for reaming. And reaming is a process where we're going to take an existing hole and we're going to enlarge it to a very, very precise diameter, within 1/1000th of an inch. So to do that, we need to get rid of a lot of the material so that we can come in with the ream later. So if we look at the plans here, there is a very extensive note written right here about the 2 holes opposite each other here. It says drill through 0.328 diameter, and then we're going to ream to a 0.34 diameter times 2. So this hole gets that treatment, and this hole gets that treatment. This counterbore and countersink for a 5/16 socket head cap screw and a socket head flat screw, we're going to discuss in a little bit later video. For right now, we're concerned with this drill through at 0.328 diameter. Now, I need to find a 0.328 drill bit. They don't make 0.328 drill bits, but what they do is go to this chart that has a whole bunch of decimal and fraction equivalents, and I found the closest thing to 0.328, and that says it's a 21/64 drill bit. So I went to my drill bits, I found a 21/64 drill bit, and loaded it up into my chuck, and I'm ready to go ahead and cut these 2 holes. I've calculated my speed to be about 1200, so I'm going to turn the machine on, dial in my speed, I'm going to add lubricant, okay, and I'm going to go to the coordinates of those 2 particular holes. This first one is going to be at x minus 3.4 and y positive 1.562. Okay, I'll drill this hole, and then I'll move to the bottom left hole, which is coordinates x minus 0.5 and y plus 0.5, and repeat the process. So on 1200 RPM, add a little bit of lubricant, okay, and we're going to do this in steps again. Cut a little ways in, clear the chips, add more lubricant if necessary, clear the chips, okay, and again, when you get toward the bottom of the hole, slow down your feed so you don't punch through too fast. And bring this up. Again, never clear chips with your fingers. Okay, grab a brush and brush those off. So now we're going to zip over to my next hole. And we're going to repeat this process here. A little bit of lube. Okay, clear it. Okay, it should be pretty close to popping through. So again, feed control is really important here. To control that as you punch through. Okay? We don't want to blast through the other side. Okay, clear your chips. Now you can see this is wicked hot. Don't go grabbing that drill bit. Okay, give it a second to cool off. But now you can see I've drilled through at all 4 locations that I need to. Okay, my next steps, okay, are going to be tapping the 2 smaller holes, and then reaming, counterboring, and countersinking the 2 larger holes.